everyone, my name is Chantel, and for this Riviera-PRO video, I'll be going over VHDL transactions debugging. And before moving forward, I just want to give a brief overview on a few concepts important to this topic. So the first term I want to talk about is the transaction. This is the main component of transaction-level modeling, and it basically represents an interaction or operation between components of a system at a high-level abstraction. Associated with transactions is an attribute, which is another important term to know. This is a user-defined property assigned to a transaction, and more than one can be assigned. These are assigned any arbitrary meaning that might be found useful for understanding simulation results. Another thing to know is a transaction stream. It basically acts as a channel or signal for transactions to transpire on. This is useful because streams make it easier to visualize all transactions when they overlap by placing them onto different streams. All these transactions can establish associations with each other through transaction relations. Relations are directed and named associations between a source transaction and a target transaction. These are also abstract-like attributes, so the user can apply their own interpretation to the relations to better understand the processes inside a design. And lastly, there are linked signals. These signals become associated with a transaction stream, and this allows for easily identifying the signals that are related to a given data flow or an event. Now that I've covered these topics, let's jump into this example design and learn more about transaction debugging in Riviera-PRO. Here I have a sample design called transactions. Since this video is about VHDL, I'll set the VHDL design as active. This can be found in the Riviera-PRO examples folder under Tools. This example design reads data from a couple of ROM memories as well as writes data to RAM memory. The RAM is known as the transceiver, and the ROMs are known as the senders. These are all instantiated as components in the top VHD file, including the arbiter, which selects which sender the data will be read from. I'll be using the project runme VHDL macro file to run the simulation. This macro performs the essential steps of establishing the configurations and compiling and initializing the simulation. Then it also opens and adds signals to the waveform viewer, and with that, opens the transaction stream viewer and adds the transactions to the waveform. Now I'll execute the macro. And here are my simulation results. So the first transaction debugging tool I'll talk about is the transaction streams window. This shows all the transaction streams created during the simulation. These streams can be added to the waveform view by right-clicking and selecting Add to Waveform. Clicking on the plus button of a stream expands to show the linked signals associated with it. These can also be added to the waveform. Now let's move on to the waveform viewer. This is the essential tool to use for transactions debugging, as it's the main visualizer for the transactions and transaction streams. In the left pane, information like the name, hierarchy, and values of the transactions and transaction streams can be seen. In the right pane, you can move the time cursor left and right, and the left side information will update as you move around. Each of these green boxes represents a transaction, visually indicating where it begins and ends. Expanding these green boxes will display all the attributes associated with the transactions. Above each transaction stream, you can see these two checkboxes labeled Count and Relations. Marking the Relations checkbox will display the incoming and outgoing transactions related to a transaction. The number of these transactions are indicated in parentheses, and you could see them in detail by expanding the boxes. When you hover over one of these relations, a tooltip will appear, displaying full details on that related transaction. Clicking on the relation will highlight and move the time cursor to that transaction in the waveform window. Enabling the count will display the substream identifiers. Substreams are just the rows of transactions in a transaction stream. These occur when two or more transactions overlap each other within the same stream. Now I'm going to go back to a relation and right-click on it, and it'll give me this option to create a virtual stream. What this does is that it creates a virtual transaction stream, and this stream will only have transactions that have the relation to this transaction. For this example, the name of the virtual transaction is relation parent, and the transactions that have a relation to this parent are the write data transactions from the RAM write read stream, and the send and receive transactions from the data send receive stream. This is really helpful for viewing all the related transactions when they're not all part of the same transaction stream. Now, one last thing I'll demonstrate about the waveform viewer is adding linked signals to the waveform using a transaction. Just right-click on a transaction stream within the Object View pane, go to Add, and then click on Linked Signals. Now the linked signals have been added to the waveform viewer. In this case, signals from the DUT were added into the waveform like clock, request, acknowledge, and data. This method helps to recognize the signals related to the transaction stream. And now let's move on to the last tool called Transaction Data. This will display detailed information in tabular format about transactions from a transaction stream. To open this, click on this icon, and a new blank window will appear. From here, just grab a transaction stream from the waveform view, or the transaction streams window, and drop it in here. Now the window is no longer empty. It now has a data grid where each transaction is its own row, and the columns contain information about the timing, name, attributes, and relations of each transaction. In this window, each transaction can be right-clicked where there's options to show that particular transaction, or set a bookmark in the waveform viewer. And that about wraps up this demonstration on the tools Riviera-PRO provides for transaction debugging of a VHDL design. These three tools together make analyzing and visualizing an already complex concept easier. Thanks for watching.